just want to jump into this. So first of all, let's start with Dinesh. Dinesh, appreciate you again jumping on, and I'll stop off sharing this screen so we can see faces. So first question that we had come up was, again, I know, as I mentioned before, you've worked with a ton of different clients on a ton of different projects, both traditional data analytics all the way through the, how do we use AI in there? But from your perspective, how do you see enterprises today using AI and ML from a real use case standpoint to be able to solve problems?
Absolutely. First of all, thank you everyone for attending. I want to start by saying, Tim, that in this hierarchy of adoption, right? You're going to see organizations that are in the exploratory phase. You're going to see organizations that are early adopters, which means they're probably in their first year of operationalizing AI or learning about machine language programs to solve their business use cases. And you have some sophisticated users. By sophisticated users, I'm talking about people that have been using AI operationally and have their machine language models evolve for the last 5 years or so. So if you're, as an audience here, if you are in that spectrum, the good news is that more than 95% of the people fall into the first two, which is the exploration and the early adoption. And the common misconception here is that AI is a binary switch. By that I mean, it's a finite destination. And it's really not. It's a continuum. And through this journey, as you're embarking on this, you're going to have very few we have arrived type moments. You're going to have business use cases change. You're going to have changing data. You're going to have the relationships between the data elements change over time. So it just like anything else, just as with your journey in analytics, just as with your journey in business intelligence, you're going to have an evolving journey, which means once you reach your first destination, you're going to have new learnings that will spark off phases 2, phases 3, and so on and so forth. But to go back to your question, Tim, this from our experience of working with organizations that have been in the BI and data analytics space and data management space, and that are getting into really AI and automated insights and machine learning use cases, the successful organizations have taken on a culture of innovation and adaptation. And as cliched as this may seem, these are the organizations that were able to ideate quickly. And then, like I talked about, the changing data, the changing scenarios, they've been able to, create their own scenarios and evolve with their findings, evolve with their learning, and adapt to changing business needs. And they haven't been afraid to fail. Now, one could ask, what does this mean in terms of operational characteristics? What does the success criteria look like for organizations, for successful implementations? Who has the edge and who struggles? So those are kind of valid questions. Those are kind of very natural questions as you're embarking on this journey. And from what we've seen with our interactions, the organizations that have had access to large volumes of data. And that's kind of one symptom where you want to be able to in an automated fashion understand the relationships between your data. And sometimes, most of these cases, these are unanticipated. You want your data to tell you a story without you asking the question. So access to large volumes of data is really critical. And secondly, you also want to have the right kind of data. It's not just the large volumes of data. You also want to set up the scenarios correctly, which means you also have to be collecting the right amounts of data. More fundamental, more prerequisite kind of things. You want to be collecting the right kinds of data. You want to be structuring the right kinds of data, and then try to find information that the data tells you. And in addition to that, some of the other organizations have had an adaptation to advanced cloud storage, just strategies around cloud. You see a lot of the organizations moving to cloud, or moving their entire application footprint, their database footprints into the cloud. Those organizations typically hold a small edge over this, or some of the other organizations.
Yeah, perfect. Yeah, and there's a lot there though that you're saying, and again, see your full breadth of how you've worked with a lot of clients in this in different places. But understand setting those real expectations at the front. I like how you kind of talked about starting with that. I think that's so important to this. I think AI and ML, at least originally started off with, it seems like a lot of large enterprises were digging into this, investing in data scientists. But as we continue to grow and the field continues to grow, we see a lot more of small and mid-sized organizations jumping in because it's things that they feel like their tools have evolved and things that they can do. Can you tell us, what skill sets do you have to look for from someone in a smaller and large size enterprise who may not have, the ability to go out and hire a full data scientist? What type of skills are they going to be looking for to be able to do this type of stuff?
Absolutely. Again, if you're a small or a mid-sized organization, you're going to want to keep the footprint smaller or the kinds of roles smaller. And there's a lot of misinformation about the roles needed. But I'm going to, from our experience and working with organizations and kind of consulting with them on what roles are needed for operationalizing AI. I'm going to talk about 3 different roles here. One follows a data journey. Another one follows a programming, a software, a computer background, machine learning type path. And another one talks about an architecture path. I'll keep it simple. And as your AI footprint grows, meaning as your business use cases grow, these kinds of roles will also evolve, and you're going to need a more skills and more different types of roles. But to start with, I'll start with the data scientists. I mean, you're going to see a lot of interpretations of data scientists, but at a high level, you're going to need these roles to be involved heavily in the entire journey of data, from your collection of data to your preparation of data to your visualization, analysis, and so on. So in this, there's a lot of internal focus areas like data quality and master data management, and data modeling, structuring of data, data warehousing, things like that. I don't want to delve too deep into those aspects, but because those are more, again, more foundational and more prerequisite type of activities. But you want this data scientist to have an understanding of that entire data journey, from the collection point, from your transactional systems, all the way to how you're deriving insights from your artificial intelligence. So, in terms of foundations, you want these roles to have a strong foundation with maths, stats, and probability, and with a good understanding of the machine language concepts. From a technology standpoint, you're looking at these roles to have Python, Scala, or the equivalents of these technologies. So if you're looking to hire for a data scientist or a person that traces the paths of the data itself, you're going to want these kinds of technologies. Now, moving on to the second kinds of, the machine learning engineers, you're now starting to move away from data, and you're moving into the computer programming with solid software skills. Now, what do these people typically engage in? They are going to be engaged in the building, the deployment, and also training complex models to perform specific AI tasks. Now, just like with anything else, you're going to have several iterations of this. So you want really strong foundations in computer science and mathematics. In addition to some of the data science itself, you're going to want frameworks. For example, TensorFlow, Keras, AWS SageMaker, native cloud capabilities. You're going to find equivalents of these technologies with other cloud offerings as well. And from a programming standpoint, you want this person to be the programming guru of this AI journey. So you want programming languages like Java, Python, Scala, or the equivalent. So that's kind of my thought process with the machine learning engineers. Now, from an architecture standpoint, we want, this is now, we've talked about data a little bit. We've talked about the computer programming. Now we want to talk about the architecture itself. These are the roles that understand the big picture of the AI initiative. And they are going to be responsible for the creation and the maintenance of everything architecture, system level architecture, and breaking down the actual customer problems into business solutions, and then tracing down the path into what does that mean from a computer engineering, from an electrical engineering standpoint. So they also have to have a lot of clarity on the products that you already have, existing products, the roadmaps on that, the functionality, feature level architecture, and how does this AI initiative that you're embarking on fit in with all of the bigger picture initiatives that you have going on. So in addition to some of the technologies that we talked about with the first two roles, you want deep neural networks, you want TensorFlow, C++, Python, and you also want to have a focus on performance modeling and optimization. So these are the roles at a high level that I think you want to start with, and as you go along, you can add more to this repertoire of AI skills.
Absolutely, yeah, and appreciate that, National. That's a lot of stuff there. Again, just and it's fun to see how the tools are evolving too, to see how those different roles are changing with that too. And I think we'll get more into that when Aditya and Renee go into more of the tool side of things, and how do those roles actually reflect into TIBCO and IBI and the tools that they're putting out, and how some of that is actually changing too. So for time's sake, let's go ahead. I want to go ahead and get to Zach with a few questions as well, and then we'll come back. I think I have a few more Dinesh we'll want to cover too, but just to keep everything moving. So again, we introduced Zach earlier. Zach's got a lot of experience from AI, starting back from NASA till his days now here with Amtex and working on the Secure project. And just wanted to kind of see, because I know some of the areas, Zach, that you work in primarily, or right now at least, are more on the financial and healthcare side. But so what do you kind of see the prevalent use cases for those industries now from the AI and ML side of things?
Sure. Thank you. So, financial services and healthcare generally are, have two things in common. And so as a result, they have a lot of common use cases in the machine learning AI space. I think one of the most common ones is the one that we probably experienced, and that's a lot on customer facing solutions to really route your customer into, different questions they might have. So if you've ever called your bank, or if you've ever called your insurer, you've had the privilege of talking to a robot voice that tries to direct you to some kind of help that you might need. And so I think the joke in AI is once you've solved the problem, it's not AI anymore. And so we might not consider that AI, but it's a major cost saver for a lot of these companies. And so that's a common one. You see that, of course, also in chatbots. One company that comes to mind, Bank of America, has a pretty high profile chatbot called Erica, can answer a lot of questions, actually inside its mobile app and stuff like that. So those are common examples. But the other thing that healthcare and finance have in common is they're really all about managing risk. And so increasingly more and more sophisticated models are being used to analyze very often temporal data, so time series kinds of data, to extrapolate trends and then turn those trends into actionable information that can either, in the case of finance, direct, let's say, a hedging strategy if you're trying to, play the market, or in healthcare could provide insight into the prognosis of a particular disease in a cohort of patients. Of course, at the population level, this is helpful to insurers, and at the individual level, this is helpful to providing the best treatment for an individual based on how they're progressing with a particular health concern. So I think none of those are sci-fi. They all exist in varying capacities today. But of course, the sophistication of those capabilities is increasing with the sophistication of the techniques available, and of course the amount of data available in these use cases.
Perfect, yeah, and completely see it as well. And I like how you use some of the common everyday ones that we see. That's always neat to hear about how some of those are things we might even think about. When we introduced you, we talked a little bit about your background doing cognitive AI. I know there's lots of buzzwords in this area of AI and ML, but that's one that we continue to come up, and we've had a number of projects that we are working with clients on that kind of come from that vein. Can you kind of tell us from your thoughts what the difference between just a traditional AI and cognitive AI, and what you see that really?
Sure. So let me address the first part. I think you're right to say that this one, we bring a lot of impressions to that term cognitive, right? There are a lot of connotations that one can associate with that. I think in the original offering of that terminology, what we were focused on as from the AI solution perspective was the idea of operating fluently in human data modalities. So what I mean by that is being able to process things like natural voice, the sound patterns that your voice makes, and turning that into something like text. And you've probably interacted with this in some capacity if you've ever played with Siri. The other thing you might want to do is get a machine to read Wikipedia and provide answers to questions. And a really great kind of culmination of those two faculties was in the IBM Watson Jeopardy playing application that made a lot of headlines and that sort of thing. But more generally, and I think where I come from, is the techniques that you use to solve these problems is really where we're focusing when we talk about cognitive AI. So there are really two camps in artificial intelligence. One is based on, the name for this is machine learning, and this is based on statistical sampling of large data sets. So you use these mathematical sieves, you push a lot of data through them, and out of the other side, you get an identification of some pattern of interest or a prediction of some variable of interest. The other sort of foil to this approach is using logic-based techniques. The idea of if we know something about this situation, we can predict or we can conclude either causally or by logical inference that this other thing is going to happen. And as it turns out, the strengths and weaknesses of these approaches are very synergistic. So, statistical-based models are really good at spotting difficult to describe patterns, but struggle to capture some of the nuances of maybe more causal ideas or things that we can very simply explain in the absence of data, which is where these logic-based methods work. So putting these things together allows us not only to predict what's going to happen, potentially with the symbolic stuff, or excuse me, the statistical stuff, but to then decide how do we intervene if in the event that the predicted outcome isn't very advantageous to us. What model can we use to dig in there and change the situation as we understand it now, cause that change to bring about some kind of better or improved situation? And so that is very generally the kind of, what cognitive AI is all about.
Awesome. Yeah, and I love that. Like I said, I continue to kind of talk about this stuff from where is that here at Real World. From you mentioned a few different things. I know you're working on the Secure project for Texas, a healthcare type of project. So you can you talk a little bit more about some real use cases that you've seen, like Secure and some of those other ones, from the cognitives perspective, and how those are being deployed out there today?
Sure. So, I'll start, literally out of this world, and then I'll kind of bring it back to earth. And so my background, a lot of our work around cognitive AI began in trying to manage and maintain the health of spacecraft. And the challenge here is that they're very, very far away, and it's not like we can go out there and inspect them and fix them. So you have to put some capability on board that allows the system to anticipate, is it degrading in its functionality? And if it is there any remediation solution it can apply to make things better, right? So in that vein, that's kind of an esoteric use case. Not a lot of people are probably going to do, risk analysis on a spacecraft. But in the case, as you rightfully bring up, in Amtex, we're working on a Secure project, which tries to combine remote patient monitoring as a data source with machine learning and cognitive reasoning to allow us to say, okay, on the individual patient level, what kind of trends can we mine from this, from the patterns we can collect in that remote patient monitoring data? And then going a step further, so just being able to forecast what things look like is certainly very helpful. But the next challenge a physician has is, how do I respond to this? And so what we want to do with the cognitive reasoning side of things is essentially provide to reduce that space of data that's generated by these predictions into some kind of actionable information, particularly some kind of modeled, this is kind of the first course of action. This is the treatment pathway we might think. Now, just to kind of, this isn't to say it replaces the doctor at all. That's still a very big stretch. But one of the things it can do is provide some initial, intervention pathway to the physician for them to analyze, as opposed to their having to read through, all of the charts, distill this data themselves. It allows them to actually, think through that, the intervention pathway, understand if it's appropriate for the individual patient in this context, and also to provide some more of that, bedside manner, as opposed to having, less bandwidth to really provide that kind of thing to their patient. So that's a very real application underway today.
Yeah, and that's very cool, because again, I think one of the questions that we aren't addressing here right now that came up though was, will that make my job obsolete? And the example you gave about the doctor, and it doesn't replace the doctor, just makes his job much more fruitful and gives him a lot of other tools to be able to do his job very well. And so I think that's a neat way to kind of talk about that. Very quickly, one last question. I know again you're in this field a lot. What do you see as the future of AI? I know there's a lot of trends in here. What do you see actually sticking around in the future when we look at AI?
Well, yeah, I think one of the good things is, in the cognitive approach, we're definitely, in terms of algorithms, we're going to continue to see refinements in things like, neural networks, and on the ML side, we're going to continue to see refinements in logic-based systems. So the good thing is whatever you're learning today will be a strong foundation for things tomorrow. But I think more topically, in terms of what are these systems going to do, I think going back to my last remark, the idea that they're going to take out some of the grunt work and allow people to focus on higher level, more strategic kinds of things. I think that's going to be the continued trend. The truth really is, as sophisticated and cool as many AI applications are to talk about, and our marketing teams like to brag about, the truth is there's still a ton of hard problems there that need decisioning by humans. And so the hope, though, is that we can free up at least some of the grunt work. You probably see this if you've written an email from Outlook or Gmail lately. You get an email and it's got a response that's pretty appropriate. Someone sends you an invoice and Gmail says, do you want to say thanks? That's fine. You don't have to think that hard about it. Go ahead and send that. What you should be thinking about is, which relationship with which vendor is the best one to make, and how do you kind of foster that relationship? And so if you can have more energy to put into those kinds of considerations, I think AI is going to be very successful in those directions, empowering decision makers with the evidence and some heuristics for making the decisions they need to make.
Yeah, perfect. Yeah, it's kind of refining the way we do our actions and our decisions in the right direction, rather than all the clutter that gets around everybody, especially with all this data out there. So thanks, Zach. I think we got a few more, but we'll move on to Aditya right now, and then we'll come back to you. I want to move to Aditya. Aditya is, again, like I said, is working on a lot of the direction for the IBI and TIBCO stack and how they're incorporating AI and ML into those. So Aditya, the first question I had for you was, especially a lot of these people on here are very interested in this, but I think most everybody here is using TIBCO and IBI products. What can they expect from an integrated experience in those products in the future?
Yep, sure, I can take that. Tim, firstly, thank you so much for having me here. In terms of a joint experience, if you take a look at AI, if you take a look at the history of an AI hype cycle, it starts with providing a platform for data scientists to build and deploy models. And then as we mature in the hype cycle, it evolved to a more self-service capability to enable data analysts, BI analysts to essentially, go into our offerings and build and deploy products without the need to code or even understand any of these coding languages. But what we see a move towards is more operationalization of AI, which is how do you enable the end experience to provide AI insights out of the box. Now, if I kind of go back to the whole TIBCO IBI stuff, there's a lot of overlap between our products, right? So, we have BI, we have data management. And so when we see AI being reflected in our products, we're seeing AI, working in the back end, enhancing the end user experience as we move from, curation of AI models to operationalization of AI models to expand to a much broader audience and making it more, business view friendly, if you will.
Yeah, absolutely, and I think that's exciting for everyone to hear. And like you said, from my experience on the WebFocus side and what I've learned about TIBCO, there's a lot of things, like you said, that are going to work well together. One of the specific things that I think a lot of people are curious about, because TIBCO Spotfire was a tool that's been around for a while, and they have had made a lot of inroads on the AI and ML side. So what is it going to look like from an integration standpoint between WebFocus and Spotfire, two tools that are not the same, but that could share a lot together?
Yeah, so we're currently working on the architectures to merge it together. Certainly there are benefits of TIBCO products over IBI and vice versa. If you take a look at TIBCO stack, they have very dense features and functionality that they've built over the last, decades. And IBI has done the same, but I think the way that we would differentiate ourselves is that we have, industry core vertical knowledge, right? And that's where we really come into play in the TIBCO stack. We have industry knowledge in credit unions and the financial services, including banking, healthcare, PNC insurance, government, etc. And we built, we have domain expertise within IBI that's now part of the TIBCO family, and we have prepackaged products that's accessible to these core industry verticals to enable them for quick onboarding. Now, if you take a look at the maturity model of an AI lifecycle, what we provide is essentially the foundational work to scale and build AI models, right? With that core industry vertical knowledge, it will enable you to start building and deploying and scaling against the use cases that you've identified in your organization. The last point I want to make here is kind of going back to the solution domain of AI. Regardless of TIBCO or IBI, we're looking at artificial intelligence as a more horizontal approach, and that's important, right? And the reason why I say horizontal is because we're going to see flavor of AI being implemented in the data management platform, in the business intelligence platform, essentially across the entire solution line. And the reason why that's important is because moving away from curation to operationalization, you're going to see elements and engines of AI, if you will, being embedded into the portfolio, so that from an end user perspective, you can get the AI insights and the benefits of AI automatically, right? So that's kind of moving towards more of a business friendly view as opposed to more of a curation of it. Curation is important, but we're seeing that movement towards operationalization, so that's going to be a heavy focus.
Yeah, and that makes perfect sense. And I think that a lot of people naturally see AI and ML being integrated into the BI thing. I think some of the things that, some of the ways that people don't think about it is from a data management side of it, is how can it help me enrich my data in a more automated fashion. So I think that's a great point you bring up. Some of the things that we also have seen, obviously, in the last decade or so, is about everybody we talk to, whether they've moved or not, has at least talked about how is the cloud going to affect my platform. So IBI, TIBCO both are both cloud and on-premise environments. So what do you see as far as from a AI and ML and the products that you guys are doing? How is that going to be affected as far as people who are moving to the cloud or staying on-premise?
Yeah, so I think it's a combination. It really depends on what kind of industry vertical we're focusing on. If we offer our products both on-prem as well as on cloud, and you got hybrid solutions and all that stuff, right? Where you have your data on-prem and you can access it on cloud. You have a lot of flexibility on that. We're agnostic from the cloud offerings, but in terms of kind of zeroing down on the cloud stuff and why we have accessibility on-prem and cloud is because certain industry verticals, they're still making the move to get their data on clouds. They're not there yet, right? There's a lot of ethical, privacy, compliance stuff they have to work on in order to get it to that state. So our products, the way we designed is to make it accessible regardless of where your data resides, right? And the last thing I want to mention, going back to the whole idea of data privacy, I'll give you an example of healthcare, right? A lot of the use cases, a lot of the core revenue generation for IBI is in the healthcare space. And that's an industry vertical where they're working towards moving on cloud. Don't get me wrong, but there's a lot of heavy lifting that's required to get them to that state. So as they migrate from on-prem on cloud, we are elastic enough to kind of adapt to their business requirements to make our offerings extendable to them as they kind of move and their architectures change.
Yeah, absolutely. Yeah, and like to hear that, like I said, it's available if you're on premise and you haven't made that move or hybrid of that, which a lot of people are, that those things really don't change. What you mentioned earlier, and I thought it was a good point about how AI can be used to enrich your data management. But kind of the flip side of that, we got a question was, what is the role of data management and the health of your AI and ML and being able to do that in the life cycle of that project?
Yeah, so data management, I always put it as a prerequisite for AI. I've been in the space for roughly about 10, 12 years now. I started off with actually predicting earthquakes, and then I moved on to healthcare, and that's where I made the move to IBM and Watson Health and all that stuff. And the reason I bring that up is because data management, data governance, data quality is extremely important regardless of what use case you're trying to tackle, regardless of what industry vertical you are on, right? And the reason why I consider data management as a prerequisite, in an AI lifecycle, if I break that down, it's kind of two facets, right? It's from a business view and it's kind of from a technical view. The most important element in the business view is that you want to capture a strategic goal of the organization. That's kind of a top-down approach, right? What I mean by that is, a top-down approach could be, you want to reduce or you want to increase sales and want to reduce risk in your organization. And as you kind of trickle down on that, you kind of zero down the use case that is going to make the most impact to your organization, right? So that's the business view. Yep. And, from a technical view, when you realize what use case you want to tackle, harmonization of data is extremely important, which is essentially to assess the data completion, which is to assess the data quality, the data governance, consistency of the data is extremely important, especially if you want to scale. And finally, once you identify, mapping your business view to a technical view, once you understand that use case and you bridge that to a technical cycle, you understand that use case, you have to map that to a data requirement, right? You have to have some sort of data dictionary to understand what data elements and attributes is going to be important, required for you to develop that use case, right? And yeah, sure, you're going to have subject matter expertise, a team that's going to be in place to make that happen. But that's that transition that you need. Once the use case has been determined, the harmonization, the impact of data management is going to be extremely important. The phrase that I used to use back at IBI when I did presentations like this was that if you don't take data management seriously, then it's garbage in, garbage out, right? Because if you don't have good quality data, then you're essentially wasting money and resources and trying to determine an end state and predict something without knowing that really the quality of data is something that you need to focus on, because without the quality of data, the predictions are not going to be impactful by any means. It's going to in fact skew the way you run your business cycle. So the impact of data management, extremely important and considered a very strong prerequisite to an AI lifecycle.
Absolutely. I love that answer. And again, it just comes back to, you can't really make decisions. You can't predict decisions, prescribe decisions or information to people if you don't have good data that you trust. So that's a huge point. Appreciate you kind of expound on that. So appreciate it, Aditya. Let's go to Renee. I've got a few questions for her, and we kind of, again, because Renee's going to be doing a lot of the demo for us, we picked some questions out for her that were more tied to individual products and the things that she may be showing. So she's going to be talking about some of this stuff, but I think you'll hear some of this stuff as well, or see some of this stuff as well in the actual demo that she'll be doing very soon. So, hey, Renee, first of all, we've heard a lot about some of the new web-focused designer tools. Now we're all excited about that. Can you tell us a little bit about how Designer will include some more of these predictive features that we've been talking about from the rest of the group for us?
Sure, and also Tim and the Amtex team, thank you for having me here today. It's a pleasure to be talking to you and the team. I really love talking to all the web-focused customers and showing them all of the wonderful new features that is in the product. And specifically regarding Designer, that is the visualization tool for web-focus. So that already has a whole lot of options in there to help end users and business analysts to be able to run some of the models that was created either from standard functions that we have deployed in Designer, or from deployed data scientists models that was deployed that I will show in the demo through the reporting server and the metadata layers. But one of the great things that we are working towards is to actually incorporate some of the model building and model testing that more of the data scientists will use into our GUI tools that are browser-based functions as well. So we are doing both sides of it, the people that actually create the data scientist models, and also the deployment of that in the Designer tools.
Very cool. I'm very excited about that. Like I said, I know you're going to show some of that, but one of the other things I think that it was a neat question because it came up, I think it really ties into what you're going to be showing, if I remember correctly, was, how can a model be used to show real-time scoring of data?
That is, to me, Tim, one of the most important parts that is often the missing link in data scientists. When they start to create models and they have a great way of predicting all kinds of things, is a customer at risk? Is this a fraudulent claim? But how do you actually put that model in the hands of business users, right? So you don't want to have to explain to somebody trying to process a loan application or an insurance claim what a neural network is. That's just, a term that they probably never want to hear. So a lot of other technology stacks require that you take that model and run data through it and then store the result, and then you can have a visualization tool that actually just presents that result to the end user. With WebFocus, because it's deployed in the metadata layer, it's real time. So you actually read that just like you would read any other function and calculation that you would have in your metadata layer. So that means that we can use that model on reports, on charts, on maps, and any other way that you would like to present that to an end user trying to make a decision.
Perfect. Yeah. And that's great. And like I said, we asked Dinesh a question earlier about some of the roles. I think some of the roles that he described are going to be different and growing as they get more into the tools. And like you're saying, some of those people don't have to be true data scientists. They can actually use some of the built-in functionalities that are there to run common models that are against the data. I think you'll show as well in your demo how you can actually integrate Python models that may already be created in there. So lots of different ways that those roles are changing and being included inside of this type of environment. So one last question kind of pertaining to models. What types of model predictions that you've seen from talking to other clients can be made?
Yeah, so we can predict categories. So for example, a yes, no, if a customer is at risk of leaving your organization, we can predict a numeric value, is that this is an 80% chance of a fraudulent claim, for example, but we can also score text. So that is often an area that is overlooked in organizations, and just getting an insight into what is it that people are saying when they are talking to you and they're submitting an insurance claim, for example, can have an influence on whether a claim is fraudulent or not. So pretty much if you can use a piece of data, we can have a prediction on top of that.
Yeah, and I love that. And of course, for my role, where I'm mainly in the front end, talking to people rather than actually, like I did in my past, actually doing things with the data and being the computer guy. The use cases, like you're saying, are just the fun part to me. So thanks for that.